Hello, so we're going to go through chapter 14, it's routing concepts. So the areas that you're going to cover are path destination, packet forwarding, basic router configuration review, IP routing table, and then static and dynamic routing. Path determination, it's within the functions of a router. So when a router receives an IP packet on an interface, so it determines which interface to use to forward the package to the destination. So this is known as routing. When the router receives and then is trying to determine which could be the destination interface, that is what we call routing. So the interface that the router uses to forward the package may be the final destination, it could be the final destination, or it may be a network connected to another router that is used to reach the destination network. So each network that a router connects to typically requires a separate interface, but this may not always be the case. So the router, it might forward the packet to the final destination, or it might route the package to the next router so that that router can reach the final destination. So the primary function of a router are the functions of a router are to determine the best path to forward packets based on the information in its routing table, as you're going to see in the coming slides, and to forward packets toward their destination. So router functions example, router uses its IP routing table to determine which path or which route to use to forward packets. So router 1 and router 1 will use their respective IP routing table to first determine the best path, and then after determining the best path, forwards the packet on the best path. So this is our router 1, as you can see there. It's router this is router 1, which is this, and the known networks, we have this 192.168.1.0 and then .2.0. So this is 2.0 and then 1.0, which is this. You can see these are connected networks. This is connected network, this is connected network. Then we have what we call the static route. Now it's the route to reach this network, which is not directly connected to this, which is F3. So this is the routing table for router 1. So every time a router receives, it will determine to see the best path to reach the destination, and then after that it forwards that package on the best path or best route. So best path equals longest match. Best path is equal to the longest match. So if, let's say, our routing table is we have 192.168.1.0/24. We have 192.168.1.0/ they're saying the destination, like the path, the path. Then slash maybe 25 192.168.8.1.0/ maybe 29. Which one would be the best path? The best path, it would be this, the one with longest match. The longest match, it's this. Most of the time, the network, the smallest network on the smallest network address on the network. So as you can see, this is /29. It would be the best path, this. So I always use this example that if you have a list, you're looking for your name. We have 3 lists. One has 1,000 names. Another one has 500 names. Then the last one has 100. Which one would be best, or which one would be easier for you to check in? Automatically, the one with less. You just come to the list with 100, you check. If you are not among the 100, then maybe you are among the 500. And then check. If you are not among the 500, then automatically you will find your name in this. So the best would be this. Note, the term prefix length would be used to refer the network portion. Network portion. And network portion of both IPv4 and then IPv6. So the statement here, it tries to mean this, that the best path in the routing table is also known as longest match. The routing table contains root entry consisting prefix or the network address and prefix lengths. For there to be a match between the destination IP address of the package and root in the routing table, a minimum number of far left, minimum of far left bit must match between the IP address of the package and then the root in the routing table. Then the prefix length of the root in the routing table is used to determine the minimum number of far left. So far left, it's this, as you can see, the prefix. The will always be left and then right. So this is prefix, and then this is the net prefix length. So this is our the left. So the left it has network portion, and then the right it has the host portion. So the network with the longest the network with the longest network portion, it would be the best destination to use to forward packets. So we have an example here that the IPv4 address has the destination address, whereby we have this. Then the router, this is the destination. The router has 3 root entries in its routing table that matches this package. So the 3, we have this /12, we have /18, and then we have /26. Of course, the one with longest match or left far bits, there are these ones here. There are these ones here. Because these ones here, they indicate the network portion. 26, and then the host portion is equal to 6. So this one here is the best when you look at this. The best is this. Then for IPv6 still it will be the same. As you can see the prefix lengths, we have 40, 48, and then 64. We cannot say that it's a 64 because when you look at the addresses, they are not the same. The addresses are not the same. The entries that are the same are these that are much. We have this and this, so we have to do the comparison between the two. So since this is less, the bits are less than this, then we are going to go with this, the one with the longest match. This. And you guys who are planning to do the certification, you'll actually answer the questions of this type, like 4 or 5 in the exam. So you need to get the concept. Path determination. In path determination, to build within the routing table, we have three. I'll say three uh, a way of learning the routes. So we have what we call directly connected networks, then remote networks. So in remote networks, we have the way of static route dynamic. So static route is almost the same as default. The difference is that static, it's for specific network. Then default, it's route that connects to many networks. But static, it's just one to one, just one route to reach a specific network. Dynamic added to routing table when the routing protocols dynamically launch. So in static, if you have this as the router and the network, you have this router with two networks. So the static, we need a route that will actually connect specific network like this. So if you create this as the static, it is there to serve this network. Let me call it A, to serve network A, but not network B. So if you want network B also to have a route from this router, router 1, router 2, so still you need another route that will connect to B. So for default static, if this is the network, you need only one route that will connect to all these networks. Then the directly connected network, there is network, because if it's this router, then this network here,
Wait a minute. Yeah, you got the phone.
so this network here, and then these are directly connected network, connected. The networks that are known by this router 1. And then the networks that are connected on this other network, these are the ones that are called remote networks, because they are not directly connected to this router. So in dynamic, all you need, because here in static and default static, you create a route. It's you, the user, the network administrator, to create a route or to provide the route on how this router is going to be able to reach these other networks on router 2. But when it comes to the dynamic, you enable a dynamic protocol, and then the protocol, it's the one that keeps on up-to-dating or sending message to this other neighboring router. For example, here you enable the protocol and then give it a network. Maybe you have network 1 and network 2. So when you enable, you advertise, you give it a networks. There is 1 and 2. So every time it sends a message, a hello message, this side, it sends the updates on this router. You know, I'm router 1, and this is the information that I know. Then router 1, it's going to, sorry, router 2, it's going to check its routing table and see, okay, I only know network 3, 4, 5. I don't know network 1, and okay, I know network 2, 3, 4, 5. But still, also you have to enable the protocol on it. So the network that it doesn't know or that it is missing, it's 1. So it will actually add the 1 on its network, 1. And also this one here, it is going to send a hello message having the information that is known by this router. And then the networks that are known by this router and are not known by this router, they will also be recorded. Now it knows it also sent oh, I know 3, I know 2, I know 3, 4, and then 5. Since 2 is already known here, it's not going to be updated under this routing protocol, on this routing table. But 3, 4, 5, they are not known by this router, so it will capture it. So that is how the dynamic routing protocol to learn the remote networks. Then the static default route, those ones are stated by network administrator. Packet forwarding. So the data link frame with an encapsulated IP arrives on an ingress interface. An ingress interface, remember there is no any interface called ingress, but when it comes to the direction, you can change. So it's this interface on the router receiving packet, and then it becomes an ingress. Then when the router you put to forward, here it is receiving, it has to use ingress to receive. When it is forwarding or the routing, now it has to use ingress interface. So when it reaches the frame reaches ingress interface, so once the router receives a frame, then the router examines this destination IP address in the packet header, and then once it examines the destination IP address, consults its IP routing table. I know the destination, but it's the destination in my routing table. So the router finds the longest matching prefix in the routing table. Then the router encapsulates the package in data link frame and then forwards it out the ingress. Now it's time to exit the router interface. So the destination could be device connected to the network or next hop router. That the destination could be like that the destination is on this port here on this port, or the destination is the next hop, the point of this on this other router, and then the router to do the same process to determine the destination this side. However, if there is no matching route entry, then the packet is dropped. So if the destination if the destination IP address in the header is not known and there is no pass, there is no any likely pass to reach, suggesting to reach the destination, then the frame is dropped. So after a router has determined the best path, it could do the following: forward the packet to the device on directly, so that this is the source and then the destination is on the same router. If the router entry indicates that the ingress interface, this is the exiting interface, is the directly connected network, then the packet can be forwarded directly to the destination. Typically, this is what you call Ethernet LAN. So to encapsulate the packet in Ethernet frame, the router needs to determine the destination MAC address associated with the destination IP address of the packet. And then the process varies based on whether the packet is an IPv4 or IPv6. Then the other option, after the router has determined the best path, it could do the following still: forward the package onto the next hop. That this is the source, and then the destination is likely to be on the next hop address. So if the entry indicates that the destination IP address is on a remote network, then meaning a device on a network that is not directly connected, that the destination is not directly connected to this router 1. Maybe it's on router 2. If the forwarding router and destination hop router are on Ethernet network, similar processing ARP and ICMPv6 discovery will occur to determine the destination MAC address of the packet as described in previous. So the difference is that a router will search for the IP address of the next hop, router in its ARP, or neighbor cache instead of destination IP address, the packet. So that is note, this process will vary for other types of layer 2 networks. That every time a router senses and determines that destination network is on another router, then it will actually check the IP address of the next hop IP address, next hop device, and then it will use that forward the packets. And when the packets reaches on the other router, the router it will do the same to search its routing table for the longest match, and then determine the destination IP address, and then such as its routing table for the best longest match, and then forwards that. After that, it will actually go through the other process of encapsulation by removing the source MAC address and destination MAC address, and then replaces them with the new with the new source MAC address, and then the destination MAC address. So if there is no match, automatically it will drop the packets. End-to-end packets forwarding, the primary responsibility of the packet forwarding function is to encapsulate packets in appropriate data link frame type for outgoing interface. That every time before a router forwards it, mostly when they are forward on the Ethernet LAN, that the marker, the frame, it has to be encapsulated. And of course, in the encapsulation, we need either new source MAC address and destination MAC address. Data link frame format for CDO link could be point-to-point, point-to-point. For point-to-point, it's different because, as you can see, it's serial link, and then even high-level data link control protocol, and then some others. So when it comes to that, the MAC addresses are not changed. It just forwards because it's point-to-point, then to the next. But if you're using Ethernet LAN, then those, they do change. So the primary responsibility of the packet forwarding function is to encapsulate packets in the appropriate data link type for the outgoing interface. The more efficiently a router can perform this task, the faster packets can be forwarded by the router. So router supports the following 3 packet forwarding mechanism, where we have process switching, process switching, fast switching, and then Cisco Express forwarding. With process switching is that every packet that reaches the ingress, because here, as you can see, we have ingress and then ingress. Every time the packet that reaches ingress, that packet, it has to go through the control plane to be processed for every packet. So if there are 10, all of them, they have to keep on going through the CPU, they are processed and blah, blah. So it is a hectic, it is a resource-intensive system method whereby it needs switch to be very powerful to sustain it. Then we have what you call fast switching, that if the first 2, for example, like the first 2 packets are processed and then the last packets are also heading to the same destination, then these other the rest of the packets, they will not go through the control plane for to be processed, since they are heading to the same destination. So it will be like the first and then second, for them, they can go through the CPU and then they are processed. But since these other packets are also going to the same, then they won't. They won't. So it's okay. Then lastly, we have Cisco Express forwarding, the most recent and the default Cisco iOS package forwarding mechanism. So it builds forwarding information base (FIB) and an adjacent table. and adjacent table. So the table entries are not packet triggered like fast switching, but change triggered, such as when something changes in the network topology. When a network has converged, the first forwarding information based on the adjacent table contains all the information that the router would have to consider when forwarding the packet. So with this one here, there is no need of packets to be sent to control plane for processing, for CPU to process them. They just from the ingress to ingress direct with the help of forwarding information based and then adjacent table. So adjacent table, it's this ingress. Forwarding information based, it's this. Then the two are always up to date. And when there is a need, then it knows exactly what is in the adjacent table. So in adjacent table, it's on the neighboring. The information based, the information that is needed by that router. Basic router configuration review, I don't need to waste time on this, and I'm not going to get tired of giving you the assignments for you to try, because once you try out this assignment, the assignments are the ones that you're going to actually be practicing in the physical practical. So this is our router here with known. These are known networks, or they connected. This is C. There is no network that is, this network here, it is a connected network. No, it depends on the scenario. Now in this scenario, since they are attached, they're directly attached onto this router, they qualify to be connected, directly connected networks. But for this router one, this is a remote network, this is a remote network, this is a remote network. But when it comes to router 2 here, this one here, it will become a directly connected, and then this side, it becomes a remote network for other 2. So you need to note that. So this is the topology. I want you in your free time to make sure that you design, you duplicate exactly what is there. It's optional. If you want, try it out. If you don't want, you leave it. So these are the basic, basic router configurations, and of which my right assumption here is that you guys, you know how to configure the basic router configurations. And then once you've done all the configurations, you can play around with this verification command. Show IP interface brief, show running config, and then filter interface, specific interface, or show interfaces to show all the interfaces, then show IP interfaces, show IP route, the pings. In each case, replace, in case let's say I want to deal with IPv6, replace IP with IPv6 so that you get information about IPv6. Our filtering commands, the commands that you saw previously here, you can filter them by putting a pipe in between. Pipes, the pipe, and then filter the section that you need. So with those sections, you can actually deal with section. You filter and say section. Which section? Maybe something like DHCP. So any the section for DHCP, it will show up. Include, and if you put include DHCP, still all the commands with DHCP the way. If you say exclude DHCP, now information with DHCP it won't be. Then begin. So once you say begin, so the information that you're going to feed it, it's the one that is always going to, it will output all, but begin with the one that you've, anything that you've stated. So notch, output filters can be used in combination with show. So you cannot use these filter commands alone. So they have to be with show. See? So packet tracer, basic router configuration review, configure devices and then verify connectivity, display routing information. The other exercise that I have given you, meaning that it is actually available somewhere online, that you can go there and borrow. If you're not sure of what to do, you can borrow an idea from there.